So I hope you remember that previously we have started chapter number 2, which is network models. We have discussed a little bit about network models, and if you can remember that in this book or in the data communication, we have two different types of data or network model. One is the OSI network model, another one is the TCPIP network model. OSI means Open System Interconnection, in short OSI, and TCP/IP, that means Transmission Control Protocol and Internet Protocol, that is TCP/IP model. Generally, in our real world, we are using the TCP/IP model. Okay, generally we don't use the OSI model, but it is very same, very similar. I think you also can remember that only basic difference between OSI model and the TCP/IP model is OSI model has 7 layers and TCP/IP model has 5 layers. Only difference is top 3 layers, that means session, presentation, and application. All these 3 layers combinedly make it into one layer, which is called application into the TCP/IP model. All other 4 layers are same in OSI and also same in TCP/IP model. Okay, that is the only difference, although we have some other differences also, but this is the very basic differences. We have discussed earlier that before we go to explain each and every one of the layer, previously we need to know, or we need to consider about the layer of the data communication. And we have given one example previously, if you can remember, that in our postal service or our courier service, how it works. Okay, how it works, that means generally we send a packet to our friend and we need to post it to the post office or the courier service, and whatever we are trying to post it, or whatever we are trying to give it to our friend as a gift or as a parcel or as a package, we need to wrap them several times, because our whatever we are sending, let's say we are sending a letter or any box or any gift or any mobile phone or anything, if you want to keep them protected, or if you keep them safe from the outside world or from the outside environment, we need to do some packaging, so that during the transmission from sending location to the receiving location, during the transmission, and the real life is so harsh, so it is possible, there is a possibility that your parcel or your package may be damaged. That's why we do add some packaging in the sending part. In the receiving part, we do exactly opposite, right? That means whatever you have added in the sending part, you will actually remove it to the receiving part, so that you can get your original package. So if you remember that we have 7 layers into our OSI model. So this is, we have discussed earlier, that if we consider the OSI model, let's consider that just for an example, that this is an OSI model, and this is one PC and that is another PC. So we want to communicate from one PC to another PC. And by the way, whenever and whatever you want to do during the any internet connection, every time, all the time, it will happen. That means all these layers, either is 7 or 5, all these layers will be responsible for sending and receiving your file accurately, error-free, and safely. Okay, so exactly same scenario of our postal service or courier service. Whenever in the sending part, let's say this is the sending part, whenever you're trying to send some data, each of the layer will add some extra bit, very similar to our courier service, that we add extra packaging. But here in each layer we add some extra bit. The name of this bit is called header file. As you can see, we have 7 layers. So we have header 1, 2, 3, 4, 5, 6, 7. That means each layer add their own header file. Okay. Also, please remember that these header files, each header file has their own responsibility and added their own protocol. Each of the layer added their own protocol information into the header file. Each protocol has their own responsibility during this transmission. Each layer added some header file because there are some reason to add it. It is not like that we have added for nothing. So we have to consider all this scenario. So in the sending side, this adding is called encapsulation or decoding. Remember this term, encapsulation or decoding. We also use another term which is called multiplexing. We will discuss all these terms in chapter number 3 and 4. But just for now, remember that in sending part, in sending side, we are doing encoding, multiplexing, or it is called encapsulation. Why we call it encapsulation, or what is encapsulation? That means we are added extra header file to our original data, each of the layer, and make a big file. All right, packet actually. So and then we send it to the receiver. That process is called encapsulation, or sometimes we call it also multiplexing, because we are adding so many protocol at the same packets, because all of the information are included into those packets. So that is another name. We can call it multiplexing. We also can call it encoding, because we encode the data, whatever the data we have. By using the encoding, we have our 101010, and then send it to the transmission medium. So that's what we do in the sending side. In the receiving side, we do exactly opposite. So you are doing here encapsulation. That means you are adding header file. In receiving end, you are doing decapsulation. Like that means you removing all this header file. Here you are doing encoding in the sending part. In the receiving part, you are doing decoding. In the sending part, you are doing multiplexing. That means you add it all together and send it through the one transmission media, multiplexing. And in the receiving part, you are doing demultiplexing. So that is the process every time and all the time, whatever you do. Please do not think that it will only happen whenever you do chatting or something. Whatever you do or whatever you are asking the service from the internet, every time it happens. Okay, encapsulation, decapsulation, multiplexing, demultiplexing, encoding, decoding, every time, because these are the basic steps to sending and to receiving the data. Okay, and each of the layer we are going to discuss in this full course. I think I told you that whenever we in the first class, that this course is all about data communication, and this is the very basic part of the data communication. Whatever you do, either it's a mobile phone, if it is a mobile communication, still almost is a similar thing. If it is a IoT, Internet of Things, same thing. If you are in a just normal conventional computer networking, same thing. So the basic networking for all these type of things are basically same, but some of the things have some other extra feature. For example, in the mobile communication, we have some other features. In some IoT communication, in sensor network, in any other network, we have little bit more other feature, but basic thing are almost similar. Based on that, you go for any other technology or tools to use it into the different scenario. In this scenario, we are going to discuss about computer networking. All right, so that's why we are considering computers only, not mobile phone, not IoT, not sensor, not anything else. Just we are considering computers, either it's a laptop or PC or server or something like that. And as I told you that this course is all about these all layers, because I told you that if you look at the book, I told you this book is written very, very nicely and very organized way, and that's why we like this book. And let me show you that in this book we know that we are doing this initial part overview. We are now doing this chapter number 2 overview. So after knowing the very basic thing about the networking, then we go for a layer by layer. First of all, we are going to discuss about the physical layer. That is how physically data is sent from one place to another place. How many tools or how many possible way we can send it. As you can see, we have digital transmission, analog transmission, so many others, transmission media. So there are so many things you have into the physical layer. After that, we are going to discuss about the data link layer. That is layer number 2. That means how we can detect the error, how we can correct the error, so many other things, medium access control, wireless LAN, WLAN, so many things. So that's why I'm saying that this is our whole course. This slide is actually the summary of our whole course. Each of the layer we are going to discuss in this data communication and networking course. Although I told you that this is a very long course, it should take 1 year, but unfortunately we have only less than 3 months, so we are not going to able to discuss everything, but at least we are trying to discuss about the very basic thing about all of it. Okay, so that you can use this knowledge in the future. Either if you are a network engineer, obviously you must need to know it. If you are going to be a software engineer, software developer, or whatever, like this way, these types of job, then still you need to know it, because it is not always you think that to do only the coding is enough to make a software. Okay, so you need to know very basic thing about our networking also. Okay, so that's how it works. By the way, one more thing. As you can see, the dotted lines, these dotted lines means logical connection. They are not physically connected. Let's say, for example, this is me, that is you. All right, this is me, that is you. I am using the application layer of a browser, right? You are also using an application layer of a browser. Now if you can see that we are actually connected, we can see, we can watch, and we can listen each other. That means we are logically connected. It is not that we are physically connected. We don't have anywhere to me, to you, that we are connected, right? So that means for all the layers, they are actually logically connected. By the way, whenever we say logical, that means it's a virtual thing, not real thing, virtual thing. We have two things, logical and physical. Logical means theoretical connection, virtual connection. Physical means, in real life we have original connection. That physical connection, we only have physical connection into the physical layer. That means my PC is physically connected to my, let's consider this is my router. 1 minute. Let's consider this is my router. This is my router at my home, and this is my PC, that is router, and this is your PC, and that is your router. That means my PC is directly physically connected to the router only, nothing else. And your PC also directly physically connected to your router. If you are using mobile data, or if you are using mobile, that means your mobile, this is your mobile, you are connected the mobile with your nearest base station, that means the mobile tower. Same thing, almost same thing. Okay, so all the dotted line you can see, these are logical connection because they are logically connected. For example, I'm using the Google Meet, you are also using the Google Meet, we are logically connected. If you are using Facebook Live, you are also watching the Facebook Live, we are logically connected. Fine. So all the connections are similar like this way. We are logically connected, one layer to another layer, sender and the receiver. By the way, in between you and me, we have so many other types of nodes. They called intermediate nodes or node. Okay. Let's say, for example, I am in Uttara, Dhaka. So I am connected. This is my PC. That is my wireless router at home. My wireless router is connected to the local ISP at Uttara. That local ISP at Uttara is connected to the regional ISP in Dhaka. That regional ISP is connected to the national ISP. That national ISP may be connected to another national ISP inside our country. Maybe let's say you are in far away. Let's say you are in Khulna. All right. So that national ISP is connected to the Khulna regional ISP. That Khulna regional ISP is connected to your local ISP. Your local ISP is connected to your wireless router, and that wireless router is connected to your PC. So that's how we are connected. All right. So between you and me, there are so many devices. So many. You never know how many. So many.
Excuse me, sir.
Yeah.
Sir, I have a question.
Yeah.
Sir, suppose from one ISP to another ISP, the only gateway is through national ISP.
No, 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 no.
Like
You
two
want to
different.
go, no, you want to go, if you need to go to the outside our country, then you actually need to use the national gateway.
Sir, what if inside our country,
If it
like
is
region?
inside
What?
our country, let's say for example you are accessing any server which is located physically or geographically inside our country. Okay, let's say that is our so let's say for example you want to access any server which is the .gov.bd. So most of the .gov.bd server are inside our country, so you don't need to go to the national gateway because our server is inside our country. Okay.
Yes, sir.
All right, there is one little bit confusion. Let's say for example we are using Google Meet and you are in Bangladesh, I am also in Bangladesh. So you might thinking it is a possibility, I don't know, that it is not like that we are directly connected within our country, so it is not going to the national gateway and go to the others. It's not like that, because we are connected to the Google server, Google Meet server. I am connected to the Google Meet server, you are also connected to the Google Meet server, and then we meet together there. So that means we are connected to the national ISP. From the national ISP, we go to the national gateway. And from that national gateway, let's say, for example, our nearest Google server is in the Singapore. So our Google Meet will go to the Singapore server, Google server. You also do the same. You go to the same way to the national gateway, to the Google server, into the Singapore, and then you can watch or connect all of this. Although all of us are inside Dhaka, or I mean, sorry, inside our country, Bangladesh. Okay, so we are all here in same country. That doesn't always mean that you are not going outside our country, because it depends on where is the server. That is obvious that our Google Meet server is not inside our country. Of course, it is outside our country. Okay, so that is another case. So we have to consider the scenario that which application you are using. Most of the server, whatever you're going to use, most of them are outside our country, except our government server. Previously, our government server also outside our country, but nowadays all of the servers are inside our country. Okay, so that is the you actually need to visualize how it's working on the background. If you can visualize with your knowledge, if you have a knowledge, you read something and you visualize how it works, it is really not that much difficult. Okay, so I have one question to you. Actually, this question you should ask me. One question to you is, as you can see, the sender and the receiver, only the sender and the receiver has the all 7 layers, but in between these two intermediate nodes, they don't have all 7 layers. I hope you can see. My question is why? Why only the sender and the receiver has all 7 layers and everything, and there is no 7 layers for any intermediate devices? Question is why? Think. I suggest you, before you giving me the answer, think logically, and also think about, let me help you, think about our example scenario. That means whenever you send the package by the courier service from you to your friend, same as here, only you and your friend have the access or allowed to access to the original data. That means whatever gift you are sending, nobody else in between you and the receiver. No one else in between you and the receiver are allowed to access to the original data or inside the package. What is it? For example, whenever you post it to the post office only check on top of it. That means what is the sender and what is the receiver, and they just pass it. They don't check. Yes, they check for security reason whether or not you have some unwanted material, but generally they don't want to see what is inside it. Okay, so if you understand that scenario, can you explain our data communication scenario? Similar, absolutely similar. Just think Try to explain by yourself and then let me know. Don't rush, because the more you think, the more you will learn. Trust me. So think.
Can you repeat the question again?
Oh,
Last time.
the question is, look at the picture. And what you can see in the picture, you can see that the sender, only the sender, and the receiver has the full 7 layers. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But in between these two, sender and receiver, these are intermediate node. None of the node has the full 7 layer. This node has 3 layers. This node also have 3 layers. They don't have 7 layers. And none of it has 7 layers. Only the sender and the receiver. So the question is why? Why only sender and receiver has the full 7 or 5, whatever. If you're using OSI model, is 5. If you're using 7. If you're using TCPIP, it's 5. So the question is why only 2 devices, sender and receiver, has the full all layers? Why not the in between 2 layers? In between these intermediate nodes. That is the question.
Is it like protocol?
It is not protocol. Let me tell you. Think about. I'm telling you again. Think about the same scenario whenever you're sending the courier service. Same thing. Think why the postman or why the courier service office do not open your package. Do not want to know what is inside the package.
Sir, because of privacy.
Of course, because the privacy. Whenever you post any package, let's say for example, you are in Dhaka, you are sending the package to the Khulna region. So there are so many offices of the courier service, in the regional office, in the main office, and then they send it to the regional office in the Khulna, then the local office in Khulna, and then your friend can get it. So none of the office will open your package to see what is inside it. They only see.
So if they
they
so
only
if
see. They
open
only
my
see.
package, then
Yeah.
it might be damaged. That's why they are not opening, and they have not the access.
Yes, they don't have the access. Actually, do they need to open it?
No, sir.
No,
They just
sir.
need to
It
transfer
is
it.
not
They
necessary.
don't need to open it.
No,
So,
sir.
so that is the clue. That is the clue. That think they don't need to open it, because they just need to know what is the address, what is the delivery address, right? So they just pass the package to the delivery location according to the delivery address. Okay. Now think about this same scenario here. Our data communication. Instead of having a courier service, we are having some router and switch, but the responsibility are exactly same. Okay, try to explain if possible.
Sir, in sender and receiver, the
Yeah.
application layer is for providing service. And,